So in this video we're going to look at stretches and compressions of toolbox functions. And the basic idea is this: if we start with a toolbox function f of x and we construct a new function g of x by taking f of x and multiplying it by a real number a, that the graph of g of x is either going to be the same graph of f of x except stretched or compressed, depending on whether the absolute value of a is greater than or less than 1. So for example, we have a simple function f of x in the plane right here, given by two ordered pairs. This is the ordered pair 2, 2, and this is the ordered pair -2, -1. If I want to graph a new function g of x that's equal to 2 times f of x, what I want to notice is that this 2 is being multiplied by the outputs, right? Because the ordered pairs are x's are inputs and the outputs are the f of x's, the function value evaluated at x. So if I have the ordered pair 2, 2, the output of 2 right here is going to be multiplied by the 2, and it's going to generate the ordered pair 2, 4. And this other ordered pair, -2, -1, this output -1, which corresponds to f of -2, it's going to be multiplied by 2, which is going to generate the point -2, -2. So this point was mapped from 2, 2 to 2, 4, and this point was mapped to the point -2, -2. And so the idea is this multiplier of 2 stretched the graph so that it was 2 times higher or 2 times further. Each point was 2 times further from the x-axis than what it was before. So this is a stretch by a factor of 2. The other guy, he's a function h of x equal to a half of f of x. Let me change the pin color here. It's pointer options, colors. Let's do a different color. He's going to take each output and multiply those outputs by a half. So the point -2, -1 on the original f of x is going to become the point -2, -1 times 1/2, which is just going to be the point -2, -1/2. And if I plot that, it's going to be -2, -1/2, and you'll see that it's only half as high as it originally was, -2, -1/2. And this other point, the point 2, 2, is going to get mapped to the point -2, whoops, not -2, the point 2, 2 times 1/2, because again we're multiplying by a half, which is equal to the point 2, 1. So this right here, he gets mapped to the point 2 input, 2 output, 1. So that 1/2 scaling factor, has made everything half as high. This was 2 units high before, now it's only a single unit. It's half the height that it originally was. So if we're working with the toolbox function, we want to look at the toolbox function, identify who he is. So f of x is the absolute value function, absolute value of x. And if we're going to create the function g of x, which is 1/3 of f of x, that just means that g of x is the function 1/3 f of x, which is just 1/3 of the absolute value function. Because I'm going to be multiplying the outputs on f of x by 1/3, I'm going to grab a lattice point that's divisible by 3. So I'm going to grab this guy right here. He's the point 3, 3. And I'm going to come over here and grab the point negative 3, 3. And you always want to grab at least 3 points. And make sure you get key points if there are any. So this point at the origin is a key point. That's the point 0, 0. And this mapping is going to take each output, f of x, and multiply it by a third. So the point 3, 3 is going to get converted to the point 3, 3 times a third, which is just the point 3, 1. This point over here, negative 3, 3. That 3, that output of 3 is going to get multiplied by a third, which is just going to give us the point negative 3, positive 1. And the origin, nothing's going to happen to him because you're going to take the output of 0, multiply it by a third, which is still going to be the point 0, 0. So I graph those points. 3, 3 got reduced or compressed by 1/3 to the point 3, 1. The point negative 3, 3 got compressed to the point negative 3, 1. And the origin stayed where he was. And then you just draw the graph of g of x through those key points that you drew. So here we draw in. Ooh, gonna struggle again. This is where I wish I had a ruler. There has to be a way to make a ruler. So it's supposed to be a straight line. Draw it with a ruler if you're doing it on written paper. And this is the function g of x. And then we need to make one more function. So let's change the ink color to something new. We're making a function h of x that is equal to h of x is twice f of x. So just 2 times the absolute value function. So again, we're going to take lattice points. Now here, if I double the 3, I'm going to be off the paper. So what I'm going to do is grab a different lattice point, one that's convenient for the mapping that I'm doing. So this is the point negative 1, 1, the point 1, 1. The origin is still a good point to grab, and then just map those points. Where does negative 1, 1 go to? Well, this 1, the output, has to be multiplied by 2, so this point becomes the point negative 1, 2. The point 1, 1, the 1, the output, 1 gets multiplied by 2, so this gets mapped to the point 1, 2, and the 0, 0, that 0 is going to be multiplied by 2, so again the origin doesn't go anywhere. Map those points. The point 1, 1 went to the point 1, 2, and the point negative 1, 1 went to the point negative 1, 2, and then draw your straight line through those points. Use a ruler if you're doing it on paper. Put the arrows on. Notice I'm labeling the points too. I'm actually writing in what the ordered pairs are. So in general, that's going to be expected.